All right. Well, my voice is, I'm having, sorry. Okay. Maybe I'll hold this like this. Okay. Okay. It's Monday. I hope you guys are doing well. Hope your weekend was good. And we'll get started. We're going to talk programming basics. I wanted to start off with, I don't know how best to do this. Just some stuff in R, okay? Set up your working directory. In RStudio, I generally, every time I start working on a file, I'll do set working directory to source file location, because generally I keep all of the files that I'm going to refer to in the same directory as as the file I'm working on. And so this is helpful. If you don't want to use the menus, you can do this directly using set working directory, and you give it the path to your directory. In Windows, the backslash is like special character, so you either have to switch everything to forward slashes or you have to use double backslashes. Yeah.
I find that usually gets reset the documents regardless of the project. Is there a way to like permanently have my working directory in one place?
Maybe. Let me see. Let's go to Tools, Global Options, Default Working Directory when not in a project. You can probably set it right here. Okay. All right. Another thing, as you work, your environment gets full of stuff, right? And so I recommend clearing everything out. Every now and then there's a little broom. You can click that. Makes all of the stuff go away. This is often an issue. People will say, my code works when I'm doing it in RStudio, but then when I try to knit, I get problems. And it'll be like object not found, okay? And if you get an object not found, it means your environment has an object defined in it that your code is referring to, but when you knit it, that object is not actually getting defined in your code, okay? And so by clearing your environment, every time you knit, R starts with a completely empty environment, okay? And so if you get that thing, one thing I recommend is try clearing out your entire environment, then running your code, and then when you run your code, you'll probably run into the same object not found error, okay? And you'll have to go back and see like, oh, I'm not actually defining the data set that I'm referring to. I'm not actually importing this file, okay? And so that's helpful, okay? If you don't like clicking buttons, you can just type in rm everything, okay? Rm list equals ls. ls lists off everything, and then rm will delete everything there, okay? So these are very useful for troubleshooting stuff, okay? I think I've seen like 5 people on Campus Wire ask about this working directory stuff, okay? It's usually like the month names file isn't like appearing and stuff, and that's probably, I'm like 99% sure it's a working directory issue, okay? This is a recommendation. Change your settings so that it never saves your R data when you exit, okay? This forces you to develop good saving habits, okay? And sometimes when you start up R, if you have like there's certain names that are like super common, right? Like X and Y and Z and results and stuff like that. And if you start up R and these objects already exist in your environment, it can mess with the code that you're working on, okay? So I always say don't save anything, okay? Start off with don't save anything when you exit R, and that way when you start up R, you are always starting with an empty working directory. So that's that, okay? So you can uncheck restore R data and then save workspace to never, okay? this is exactly what I just said. All right, another useful shortcut is toggling comments in your code. So I think everybody's done this where when you're writing a script, you want to just like temporarily disable some lines, or you want to like put in a line like when you're troubleshooting, it's very common to type in like print the value of x, print x, so you know like what the value of x is before it enters into a loop or a function, and it helps you troubleshoot bugs and stuff in your code. But then you might have like whole sections that you want to like comment in and out, okay? So you can hit Command or Control-Shift-C, and that will toggle entire blocks of code, right? So here's some code here, Control-Shift-C turns it into comments, Control-Shift-C untoggles it, okay? It's like very useful shortcut. When you're writing scripts, you can create a new script very quickly. Command-Shift-N, Control-Shift-N will create a new script. And then I think you guys know this. You can go line by line through the script, or even your R Markdown code by hitting Control-Enter or Command-Enter, right? It goes line by line through your thing. Okay. You can source to just load up that entire script. And you can also, there's a keyboard shortcut to source the thing. So this is useful when, so this is basically, you make changes to your script, and then Control-Shift-S will save that script and then source it immediately, which can be handy. Okay. So these are just useful keyboard shortcuts that I use frequently. Okay. And then other useful shortcuts, clearing the console, right? So as you work, your console gets full of stuff. Control-L clears it, so you're back at the top. And then sometimes R starts acting funny. Control-Shift-F10 will restart your session, and that wipes your entire environment, clears out any packages. And then when you're dealing with RMD files, you can knit it, and that's Control-Shift-K or Command-Shift-K. Okay. Of course, you can always click the knit button and whatnot. All right. Okay. So now we'll just get into basic flow control. All right. And so the important thing is we often work with logical vectors in flow control. And so we have vectorized logical operators, and or and not. There's also exclusive or. Put the colon in the wrong space there. All right, and then you also have the non-vectorized versions of or and and. Okay, the double or and the double and. Okay, and basically, if it's vectorized, it'll take logical vectors and go element-wise, and compare them and return a vector of values. And non-vectorized, it will only look at one object and return only one value. So basically, if statements, if you've got an if statement, use the non-vectorized versions, because if statements can only take in one logical value. You can only have a single logical value there. So the non-vectorized or the and is best for preferred in if clauses here. Okay. All right. So quick quiz here. No points at stake, but internally ask yourself what is true or NA, what is true and NA, what is false or NA, and false and NA. You can write these down or you can talk to your neighbor.
I think these are logical expressions. That's all I got.
Okay.
Double single line before.
All right, true or NA, what's that going to be?
True.
True, okay. True and NA? This one's going to be NA. False or NA? False or NA is NA. False and NA is false, okay? So here we go, all right? So, I mean, these ones you know, right? True or false is true, true or true is true, false or false or false is false, false or true is true, NA or true is true, NA or false is NA, NA or NA is NA, okay? If you do the and statements, true and false is false, true and true is true, false and false is false, false and true is false, okay? And then NA and true is NA, because you don't know if the NA is a false or a true. NA and false is false, okay, because at least one of these is definitely false. And then NA and NA is NA, okay? I think it makes sense, right? Okay, and then if you use the non-vectorized, the X double OR, it's just going to look at the first value, which is true. The X double and Y only looks at the first value and gives you false. Okay, you have exclusive OR, and this basically, it's like OR except true, exclusive or true returns false. So one has to be true and one has to be false. Okay, so it's only going to be defined where both are given. So you have true or false, that's true, true and true is false, false and false is false, false and true is true, and then anytime one of these is undefined, it gives you back NAs. All right, here's any and all, okay? Any and all are like generalizations of or and, okay? So here, U is all true, W is all false, and V is a mix, okay? So if I say any U, I get true. Any and V, where any of these are any of these values true, I get true. And W are any of the values in W true, that's false, okay? Are all the values in U true? That is true. Are all the values in V true? That's false. Are all the values in W true? And that's false. Okay, so that's fine. All right, here's the hard question. Okay, we've got a rule that any with a length 0 logical vector with V should be the same as any in V itself. Any of V itself. All with a length 0 logical vector in V should also produce the same result as all of V by itself. Okay? So with these rules in mind, and then don't cheat by going on your computer and typing this in to get the answer, okay? So with these rules in mind, what should any logical 0 return, and what should all logical 0 return? Go ahead and talk to your neighbor, see if you can figure this out. I should hear neighbor talking.
I'm not disagreeing with you. I'm just saying, like, well, so if we know that, what is it? I know there are generalizations of ornament. Yeah, that's true. Any law is what?
All right, I think some of you guys went ahead and just typed this into your computer to see what it produced. But let's go ahead and look, okay? So here are my vectors, U, V, and W again, okay? So any logical 0 is going to return false. All right, let's take a look why, right? So here X is a logical 0 vector, and if I say any X, I get false. All right, so here if I do any U, are any of these values true, I'm going to get true back, right? And then if I mix that, combine x and u, I'm going to have a vector of all trues plus false, and the result is still going to be true. Okay. Here with v, are any of these values true? That's also true. And then if I throw in another false value, the answer is still true. Okay. At w, are any of these values false? Are any of these values true? That's false. Okay. If I combine w with the result of any logical 0, okay, that result needs to be false. Okay. So if logical 0, if any on logical 0 returns true, then this answer would be false, but then this answer would become true if the logical 0 returns true. Does that make sense? Okay. Similarly, for the all statement, all on the logical 0 is going to return true. And that's because if it returned false, this first answer, where it's all true, okay, all on u by itself returns true, but then if this thing returned false, this thing would change to false, okay? Adding an additional true to v or w isn't going to change the results that it's false, okay? So all on the logical 0 is going to return true. All right, here we got some comparison operations, right? I think all of these are vectorized, so you can take a vector of x and a vector of y and do, you know, is it greater than, less than, or equal to, or not equal to, and stuff like that. And you're going to get vectorized inputs and vectorized outputs. Okay. All right, let's talk about if, right? So we can do conditional statements with if. All right, and it expects a length 1 logical vector, so just one true or one false value, and it can't be an A, right? So if you give it something that's more than length 1, you're going to get back a warning, and if you give it an NA, you're going to get back an error, okay? Usually we use curly braces to block all the statements, although if it's just a single line, you don't need it. Okay, so here I've got x is the vector 1, 3. We ask is 1 in x, that's true. And basically this is if true, print hello, and because the if statement is true, evaluates to true, it carries out the action. Not surprising here, okay? Here, this statement, x greater than or equal to 2, is a length 2 logical vector, okay? So it gets false true, and what happens is in the if statement, it evaluates this and it produces a warning, and because the first element is false, it does not execute the code inside the curly braces. And so it just gives us a warning and doesn't print anything out afterwards. Okay, it doesn't execute anything inside the braces, but it does give us a warning that I did an if statement and you gave me 2 logical values, and I just used the first one. All right. Okay. Same idea here, except the first one's at true. So it takes the first value, gives us a warning, and then it executes the code because the first value is true. If you want to, if you want something where you've got like a logical vector longer than length 1, you can throw it into a statement like any or all, okay? And that takes a, you know, length whatever logical vector and returns just a single value, all right? So this won't complain at all, right? So any on this, one of these values is true, it gives us back. On the other hand, if can't handle NA, you're going to get back an error. So here I've got x is 1, 2, 3, and then if I do x subset 5, that's an NA value, right? So we say x subset 5, and so this is going to be if, and so here's an NA statement, right? And then we get this error in this missing value where true false needed. Okay, so anytime you see this missing value where true false needed, that's almost certainly an if statement with an NA in it. Okay, so one of the difficult things about learning R is understanding its error codes, right? You type something in and it throws back errors at you, right? And you're just like, well, I don't know what I'm supposed to do with this, okay? But certain errors pop up frequently, and when you see this error, you can say, oh, I know where I messed up, right? So subscript out of bounds, you're trying to pull something, probably using a double square bracket somewhere, and you're giving an invalid index, okay? Or maybe you're subsetting a matrix, and again, you're giving it an index value that's outside the range of the matrix. Here, this one, missing value where true, false needed, this one's almost certainly an if statement where you've given it an NA, okay? And you're gonna have to go back through your code and say, why am I getting an NA here, okay? What can I do to get rid of this NA? And it could be one of the situations where you have an OR statement and one of the values is NA, right? And it can't figure out what to do with it. All right, we've got the if and the else if and the else. These are nesting statements, right? And so the else only gets looked at when the if is false, okay? So here we say x is 3, is x less than 0, that's false. So it evaluates this and it comes back positive, and yeah, x is greater than 0, that's true. And so it comes back and says positive, okay? For x equal to 0, this is false, so it evaluates this. This is false, so it evaluates the final else, and it gives us 0. Here, if you do something like this, right? X is 3, and we ask, is x greater than 0? That's true, and so it skips everything else, okay? If it evaluated this if statement, this is also true, and it should run this code. However, because it's attached to the else, this will never get evaluated because this statement is true, right? So if the original if statement is true, it will never look at the else, okay? A useful thing is the if-else statement, okay? So one thing that's really great, and I'm going to talk about this later if we have time, is that the if-else statement is vectorized, right? So sometimes you want to do something and you want to kind of like, if x is 5, say yes, otherwise say no or something. This kind of statement can be reduced to, you have a logical test, and then this is the value that you get back if it's true. This is the value you get back when it's false, okay? And this is vectorized, and so you can take a vector and throw it into the if-else statement, and it's going to give you back a vectorized result as well, okay? Which can greatly speed up your code, because in this case, for the if statement, you've got to subset each. If you have a vector x, you've got to kind of subset to just one value at a time, run the expression, and then update your outputs that way. All right, let's take a look at some loops here, okay? All right, so I think you guys are all familiar with the for loop, and it's just going to take a vector and it's going to do some kind of operation to everything in the vector here, okay? So here I say for x in 1 through 10, cat, which outputs to the screen. You've got some homework questions about the difference between cat and print. Have you guys figured that out yet? So a hint is cat doesn't return anything, right? Both of them output things to the screen, but print, prints out the object. So I don't want to say too much more, right? It's for you to explore. Okay, for loops can iterate through any vector. So here I've got a list. A list is a generic vector. And you can just say for y for each item in the list, right? So if we think about this list is a length of what? A length of 3. And what it's going to do is it's going to go to the first item and then ask what is the length of the first object in the list. And it pulls, it's going to say that's a length of 3. What's the length of the second object in the list? And that's going to be 7. And what's the length of the third object in the list? And that's 2. Okay, so it just runs through the list. I think we're most accustomed for a for loop to run on like some integer vector, like 1 through 1,000 or something like that, sequence along, a vector and it produces integers. But it can run on any vector, really. Yeah.
In stats 20, our professor pretty heavily discouraged using loops.
Heavily discouraged using loops? Okay, that's fine.
Is there like something wrong with loops in R? I've never like fully understood.
No, nothing's wrong with loops in R, except that they can be slow. Okay. Yeah, I understand the reason to discourage loops. Okay. Loops are easy, like, to think about. Okay. Our brain, loops is I think a relatively easy programming concept to explain to somebody, right? Because we're all accustomed to the idea of like, I've done one thing and I'm going to do the exact same thing again, right? But just maybe change something else, right? This is what you're doing when you're copying and pasting code, and you're just like modifying a little bit. You're just like, first I'm going to do it for this, and then I'm going to do it for this, and change it to like X, and change it to Y, and change it to Z, and things like that, right? Loops are great, but they can be inefficient, and R is notorious for being slow with loops, okay? You have compiled languages like C that take a loop and then it says, oh, I can optimize this and stuff like that. R is an interpreted language, which means it runs each line, it executes each line line by line, okay? And so if you have a for loop with like 1 through 10 million, it's gonna literally execute each line one at a time 10 million times, and so that can slow things down. Yeah, if you can do something without using a loop, it's better, okay? If you can't think of how to do it without using a loop, then just stick with the loop. That's fine, okay? But if you can, a lot of times you can do something without using a loop, and you're better off. Is that a question? No, okay, you're fine, okay. Okay, so here's another example. I've got a vector of characters, state names, Alabama, Alaska, Arizona, Arkansas, California, and then here I'm just running this for loop, for each state in this state names. We're gonna print out to the screen, the state name has the number of characters in it, okay? So California has 10 letters in it, okay. All right, when you run a loop and you store your objects, okay? So here are just a few examples of things that aren't great, okay? So here, so this is an example. So I'm running from 10 to the 8th, what's that, 100 million, okay? 100 million, and I'm squaring every value from 1 to 100 million, and I'm storing it, okay? Here, the best way to do this is to create an empty vector already of length 100 million, okay? And then you update the, for each value, you're gonna square it, and you're gonna store it in its position in the vector, okay? One thing, if you don't define it, right? So here, I've created this vector of a length 100 million. Another option is you can be lazy and you can just create a numeric vector and say, well, R will figure this out, right? So it's like the exact same code, right? Except I've timed it. And every time you do this, R has to resize the vector, okay? R has to resize the vector, okay? And so the original code took us 13 seconds. This one took us almost a minute, about 51 seconds, okay? And this is going up to 100 million. All right, and then this one's the worst method, okay? Here I'm only going up to 100,000, okay? 100,000, so actually that's 1/1000th of the work. The other ones we went up to 100 million. This one we're only going up to 100,000, but look how long it takes. It takes us 25 seconds just to do 1/1000th of the work. So if I did the whole thing, probably would take 1,000 times as long, 24,000 seconds. And what I'm doing here is I'm starting off with an empty vector, and then I'm taking the entire, like this is a common thing that people do, and it's okay if you're dealing with small amounts, right? But if you're doing this and you're doing anything basically over 1,000, this will significantly slow down your code, where you're basically copying the results and then appending another value to it, okay? And this is quick and easy, and it's a shortcut. It's easy to write in your code, but it really slows R down. Okay, so this is how long it takes to do a very simple operation where we're going up to just 100,000. And if we wanted to do the whole thing like this, it would take us way, way, way longer, right? So it's best to create some place to store everything and then place it into the index. All right, other loops, we've got the while loop, okay? And so here we're saying while I is less than or equal to 10, execute this, all right? So what is, at the end of this code, what is the value of I? 9, 10, 11, 12. What do you guys think? All right, think it in your head, okay? You guys all came up with your answer in your head? Is I going to be 10 or 11? I'll just show you the answer. Okay, I is 11, right? And that's why it exited the code. Okay, so it produced 100 here, okay, and 110 squared gets stored in. The I becomes 11, and then it hits the while loop. I is no longer less than or equal to 10, so it exits the loop. Okay, so 11 squared never gets stored into the results. Okay, something very similar with the repeat. Okay, this is like it's like while, but while true. So this repeat will always run until it hits a break statement. Okay, if you have a repeat loop and you don't put a break statement in there, it's going to run forever. Okay, so you need to have a break statement. A break statement is to kind of just say stop the loop. Right. So here's pretty much the same thing. When I hits 11, okay, then it breaks. Okay, so it keeps going. 10 squared goes in. 10I becomes 11, and then at I is 11, this becomes true, and it quits the loop. All right, so we've got break and next. So break exits the loop. All right, so if I execute this code here, so it says for I in 1 through 10, if I is divisible by 2, all right, I mod 2 equals 0, break. All right, and then as you execute, print out I to the screen. All right, so what is this going to output? All right, you guys have an idea what it's going to put out? It's going to just put 1. All right, so it's going to hit 1, and then when I gets to 2, that if statement becomes true, it breaks, it quits. Okay, so this is all we get out of the screen. Okay, what about this? Here I've got next. So same exact code, but instead of break, it does next. Okay, so what next does is, as soon as it hits a next statement, it goes immediately to the next iteration of the loop. It doesn't execute any code that comes after. Okay, it skips any code after the next statement. It goes immediately to the next iteration of the loop. So what is this going to output? Okay, so well, let's think about this. I1, the if statement is false for I is 1, so it's going to print 1 to the screen. Okay, then it goes to the next iteration of the loop naturally because it reached the end of the loop statement. So we get 2. All right, for 2, what happens? The if statement becomes true, and so it's going to hit next. Okay, so as soon as it hit next, it goes to the next iteration of the loop and it hits I is 3. Okay, so for 3, that if statement is false and it's going to cat 3 to the screen, and then it'll go to the next iteration of the loop because it reached the end of the code, and then it's going to hit 4, and 4 will hit the next statement. So we end up getting just the odd numbers output to the screen. 1, 3, 5, 7, 9. Okay, we've got sequence length and sequence along. Okay, we often create lists and stuff by doing, loops by using like 1 through 1,000 or something like that, 1 through length n or something. Here, I've got list L, and I did sequence along L, okay, and it basically runs through the code. It's very similar to the for loop that I had earlier, okay. It looks like 1 through length L, sequence along L, and sequence length of length L. These all look similar, right? And they look similar for standard inputs, okay? But there's a difference if you have a length 0, right? So if you use 1 through length L, and L is a 0 length vector, okay? 1 through length L is going to produce this vector 1, 0, right? And so if you have a loop that says for x in 1 through length L, we're going to run into problems because L is a length 0 vector, and then so here I just want to print out the length of this thing, and so it's going to subset L using double square bracket 1 for the first iteration of the loop. And so this causes an error. We get a subscript out of bounds. Okay? So to avoid this, you can use sequence length or sequence along. Sequence along L produces an integer 0 vector. Okay? So here the difference is, here I did x in 1 through length L. This is going to produce a vector 1, 0, whereas this, for x and sequence along L, that's a length 0 vector, okay? So an integer 0 vector, and so this, nothing gets executed, right? So it says for x in 0, it just says, okay, well, there's nothing for me to do, okay? So this we won't run into any errors here. Okay, let me talk about vectorizing your code very briefly, right? So, so this is what I want to say about optimization, okay? If you can optimize your code and vectorize it, great, okay? But sometimes it's not always worth the effort, right? Maybe you optimize your code and you save like 10 seconds in execution time. Maybe that was good. Maybe it's not, right? Maybe it wasn't. It's not worth spending hours and hours just to save a few seconds, right? If your code is really long and you can't handle, like, you try to run it and it takes like an hour to do something, okay, probably should spend some time to try to fix it up, right? So if you're aware of these vectorized operations in R, you can save yourself some time, right? So R features two functions, row sums and column sums, and these are very, very, very fast operators for matrices, okay? If you can think of what you're trying to do in terms of row sums and column sums, try to write your code that way, okay? So, for example, I'm going to create a big matrix, okay? 1 million rows by 100 columns, and we want to find the mean of each row, okay? So this is a big operation. And so here I created a matrix, okay? 1 through 100 million, make 100 columns in this thing. We're going to store the results here. This is the proper way of kind of doing this. And here I subset the matrix by row. I do x square bracket I comma, and I'm going to say take the mean of that row and store it in results I. Okay? Not so bad. It takes about 10 seconds. Here I can use an apply function. Okay? Apply to the big matrix X along margin 1. The function is the mean. That takes about 15 seconds, okay? But look how fast using row sums is, okay? When I do row sums, okay, row sums on this thing divide, so I want the mean, right? So the mean, you just say, okay, well, this is going to be row sums divided by the number of columns, okay? I do row sums divided by the number of columns. That takes 0.31 seconds, okay? So this is, row sums is very, very, very fast. If you can think of your operation for a matrix in terms of row sums or column sums, you're going to save a lot of processing time. Okay, all of these produce the same results. Results 1, 2, and 3 are all the same. Okay, here is one issue when you're trying to vectorize is that if statements are not vectorized, right? So this gets cut off. But here, you know, this will result in a warning because I'm trying to do something. So I'm just doing like, you know, red is some value, blue is some value, and we're just going to compare is red greater than blue, okay? And if it is, we want to pull out some value from the winner function, okay? So the winner is actually vectorized itself. So one way to do this is we can subset each thing, right? So we can say, look at the first value in red, look at the first value in blue, and then whichever one is bigger, either return back the first value in winner or 1 minus the winner, okay? And we can do that, and we get, it takes us about 2 seconds to do a million of these operations. Here's the if-else statement. If-else is vectorized, and we can do compare the vector red versus blue, and then it can also return the corresponding value in this vector winner, okay? And this operates much more quickly here. So so anyway, we've got that. Okay, we'll end here for today. We'll see you guys on Wednesday. I'm finishing up writing homework 2. You can expect to see that posted soon.